Hi everyone, I'm Sherban and today I'll show you how to read and manipulate your data from your tables into your Java application. So last time we created a database structure and some mock data using Flyway, and today we would want to actually read that data in our Java app and also manipulate it, so update it, delete it, and so on. We will use Spring Data and it behind the scenes will use Hibernate. So we will talk a little about Hibernate and the more general concept of object relational mapping. So the idea is that we need, or it's useful to have, let's put it like this, it's useful to have a middleware library which maps between the relational model of the database and our object-oriented model. More concretely, let's think about our example from last time. So you have a table for the teachers and a table for the topics that the teacher teaches. Okay, in an object-oriented sense, actually you would create a class for the teacher, which has a list, so it aggregates a list of topics, right? So there is a small difference because actually in a database you cannot really, or most of the time you cannot really store a list. So that's why we need to create this foreign key and to map it in a relational way. So the ORM would come here to help us and populate that list for us based on the foreign key, right? That's one of the usages. The other usage is, for example, if we would have a date column, the object relational mapper would know what kind of date object to create in Java. Right? A local date, for example, or a Java util date. So actually this could also be done by the JDBC layer, but for more complex types, the ORM would step in here. So in my opinion, these are the two use cases where ORMs really shine. So mapping collections and relationships and mapping simple properties. But I would actually recommend also checking out stuff like JOQ, which I think are better for read-only scenarios at least. Okay, good. I would also talk a little about the proxy pattern. So this is a pattern used extensively by Hibernate. And the use case, we could discuss a little about it. Basically, if you think about our example with the teachers and the topics, you could think of two moments when to load the topics of a teacher. Either you load them eagerly when you load the teacher, so when you request, okay, give me teacher with ID 1, it automatically loads all the topics for the teacher, but that might be wasteful, right? Because you might not need it always, right? So for example, if the teacher just wants to change his name because he got married or she got married, then you don't need to load all the topics. So another option would be to load them the first time they are needed. So the first time you do a get on the topics list, then you have to load the topics. Okay, so for this kind of scenarios, actually, Hibernate does not just return to your instance of the teacher class, it wraps the teacher instance with a proxy which behaves like the teacher class, but sometimes also calls the database. So when you have these kind of lazy relationships or lazy properties, actually Hibernate uses a proxy, and when you call a get on it, you might actually trigger SQL query. So that's really important to know. Okay, good. So enough talking. Let's just go to our code. So we have the code from last time. And I'll create a new package. It has to be beneath the package in which the main class is located, because Spring automatically Spring automatically searches all the packages beneath the package in which the app is located, and also this package. So the entities have to be either, or the entity classes have to be either in this package or in sub packages. Okay, and we will create so-called entity classes, and classes which correspond to the database tables. So I'll create a teacher class. So this teacher is an entity, as we already discussed, and it has ID. which is a private int ID, and it's actually a generated value. So if you remember, we used the auto increment. Okay, so this will be used. Actually, this tells Hibernate to expect that the database will generate the value and it should not try to generate itself. Okay, and we will have also a string, which is the name, right? Okay, we want to have getters and setters, so we use the data annotation and it will automatically generate getters and setters for us. It also generates equals and hash code and toString, which are not really that helpful or not the best in our setup, but I would not go into that right now. I think it's enough. For most cases, data works pretty well with entities, at least for trying out stuff. Okay, and I'll create another class for a topic. Okay, so it's again, I just use data, entity. I'll copy paste these two because we also have it here. Let's look what else we have. We have a teacher ID. So it's a many to one if you look at it from this perspective. Okay, and here I'll say that we have a join column and the name is teacher ID. Okay, good. What else do we have? We have a minimum final score. Minimum final score. Minimum attendances. And string, which is final score formula. Okay, you will notice that I used, of course, camel case because we are in Java, so we have to use camel case. It's really, really important that it matches the names that I wrote in the database, but with this transformation that instead of underscores separating the words, I use camel case. Okay, so let's start the app to see if anything happens. And I expect that probably nothing will happen. Okay, so it worked. Okay, so there is a property in Hibernate that we will use to validate the database. I'll open up the application properties reference and I'll search for DDL auto. So this is this property and I'll set to validate. So it will check the database structure and see if there are any inconsistencies. Let me move myself here. Good. So there is no error. It looks like it's okay. Let's validate this a little. So if I go into the topic class and let's say I change these two names instead of minimum to have a min and restart, it should actually die and tell me, okay, you don't have this column, min final score. Yes. So let's see, missing column, min attendances, right? So again, notice that it changed, it performed the mapping of the name from this camel case to this underscore case. Okay, so how could we fix this? Well, there are two options. Either we change it back or we could use a column annotation, say name equals minimum attendances. Tendencies. Okay, and if we restart it to die because of the final score, of course, also change this, right? So yeah, exactly what I said. So let's see if it works. So now it works. Okay, if I need to do the same kind of manual mapping for the table names, I could use a similar annotation which is called table. So add table and name equals, and here I would write the name, right? I don't need to do this if it's the same. So in this case, topic is the same as the one on the database, so I don't actually need to do this. Okay, good. Now, so we have this mapping which seems to work. Now we want to write some classes which are able to read data from the database. So we need some classes which actually create these instances for us, and then also when we do a save to send the data to the database. Before that, we need to discuss slightly about the concept. And this concept is the IoC container. So here we start going into Spring more in depth. Basically, Spring, as if you remember from the first or second video, it's a dependency injection framework, right? So then it has a container which holds all your instances and, well, methods to generate your instances, and you don't need to create instances for manually. This mostly is used for classes which are, for example, repositories, data access classes, service classes, so classes which contain your business logic. It does not hold for uh, entity classes. So in the case of entity classes, you will not use dependency injection for sure. Uh, it's pretty simple. The cut is like this. So classes which hold data, you for sure will not use dependency injection, and classes which hold behavior or hold configuration values, there you would use dependency injection. So the inversion of control container is, you can think of it like a big box in which you have a lot of instances and a lot of metadata on how to create instances, and Spring gives you instances from this box when you need them. More concretely, you could define, or you get instances from built-in sources. We will see immediately some of these built-in sources. You could annotate methods with @bean. These methods have to be in a class annotated with @configuration, and then the return value is a bean. It's an instance in this box, in the container box. Or you could annotate classes with a @component annotation, and then Spring will know to instantiate this class for you. If you have any parameters in the @bean method or any constructor parameters for your @component classes, then Spring automatically pulls the instances from the IoC container box, let's call it, to pass values there. So all this connection of existing instances to new instances is done on the fly. You don't need to know about it actually. Okay, we will create some interfaces now for the repositories, and actually Spring will implement them for us, the interfaces, and we'll put them inside the box. So we will use a special kind of syntax for defining repositories. And it's very important that we define the names of the methods appropriately. So there is a naming convention in these methods, which then automatically translates to SQL queries. So basically, if you say find by last name and first name, like is in this example, you would get a where, which checks these two conditions, right? So let's just jump into it. I think it's clearer when you see the example. I'll create a new package. Again, it's really important that it's in the same package or in the same super package, let's call it, as the application class, because Spring scans by default this package and all sub packages for this @bean and @component classes, and also for these interfaces for the repos. So everything has to be beneath the backend application class. Okay, so repositories would be our new package, and I'll create a repository interface for the teacher. So I'll say teacher repository, and this extends the CRUD repository which is from Spring. Again, so it has two generic parameters. The first one is the entity class, and the second one is the type of the ID. Okay, and let's create one of these special methods. So list teacher, so it will retrieve a list of teachers, find by name. This actually will do a query for us based on the name field, and that's it. We don't have to write any SQL. It will know to do it for us. Okay, and normally I would create also an interface for the topics. So let's just do it fast. Add repository again. The entity class and the key type. And now we could test and use these repositories. So I'll go on and create a bin. And we'll create a command line runner. A command line runner has a special kind of meaning in Spring. It's invoked once the application starts, right? So if I have a bin of this type, Spring knows to pull it from the box and run it immediately once we start. So I'll just call it on start. And I'll use here the inline lambda. Okay, and if you remember, I said that when you instantiate a bin, either with the bin method or with the add component on the class, you can get some dependencies from the outside. So you can instruct in the end Spring to give you stuff from the box. So I can just tell it, okay, give me a teacher repository. And Spring will just, the logic of Spring would be like this. It will scan this class, all these packages, and it will see, okay, I have a bin method. It returns a command line runner, so it's for sure a bin. And in order to call it, I need this dependency. So then it will continue scanning. It will see that this is a Spring Data JPA repository or a Spring Data repository, just because we extended this special interface. And then it will say, okay, I have all the info that I need to create a teacher repo because I just extended the interface. It creates a repo for us and passes it to this method. We then create a command line runner, which then Spring executes once all the process is finished, so once the app started. Okay, so let's do some stuff with this repo. So we can say repository. So let's first find the teacher or a list of teachers by name. I'll just print them. So system.out.print. Okay, so I'll print the teachers by name, and here I have to specify a name, of course. Let's look in the mock data to find the real name. So Flor Lovat. Let's start it and see if it prints anything. Afterwards, we'll do also insert and so on. Right, so it found it and it printed it for us. Okay, let's see what other methods we have in here. We could use the find one, or we could use find all actually. This would return all the teachers. Let's print something before, so by name, so we can differentiate. Then all. Then let's find one by ID. By ID. So find by ID. Let's say 5. Try it again. So here on the by ID, I obtained optional. So for example, if I enter here ID that does not exist, I'll get the empty optional. We will actually use this a lot later because it's very easy then to check if it does not exist. See, it's optional empty. If it does not exist, then we do some other logic. Okay, so this is for reading stuff. Okay, so it might be useful sometimes to check also how the SQL looks like, the SQL that Hibernate runs for us. So for that we can put a couple of properties. I just googled them before. Also a little group them together. Okay, let's see if it works. I expect basically at the end of this that I will get some SQL printed. Right, so here you can see the SQL that it runs. It's pretty ugly, but says, okay, select teacher ID, teacher name, from teacher where teacher ID equals, and then it says, okay, the first parameter I bind to 111. This binding is a concept which is used mostly for SQL injection prevention, but I will not go into that. Okay, good. Let's also save something and delete something. So we could do a repository save. So I'll add myself. So I'm equals to a new teacher. I say that my name is Sherban Rescu, and I just save myself and do a print on the result. It should return to me the entity with the ID also in it. So let's see what happens. So ID is 26. What do you think will happen when I run it again? ID is 58. I don't know exactly how it reached that 58, but whatever. The idea is that in the end, it creates another entry. So if we look in the H2 console, we will see that there are two different share bonds right now. Okay, so then maybe I want to find all of the share bonds. So here I get all the share bonds, and then I maybe want to remove them because I'm not a professor at the university. Okay, so there is a method called delete all that I can pass a list. And here you can see that it actually runs this delete. Right, and it does basically 3 deletes in the end. So I ran this insert 3 times, so it had to delete 3 different. The 26 the first time, the 58 this second time, and the 90, which is this one that I inserted right now. Okay, good. So that's deleting, creating. Let's also update something. So if I say teacher, what was his name? Floor. Find by ID. I think his ID was 11. And get, this is a very bad practice. Or let's do or else throw. Throws the exception if it's not there. It's a really nice construct to use, not with the runtime exception, we'll see next time, but nice construct to use when throwing an error when you want to read a single entity. And then floor, I set the name to blah, and then say repository.save. This is actually not necessary all the time, but in our case, let's just do it. And then I'll do again basically this, but with 11. See that it actually worked. So it seems that it worked, right? It said the teacher with ID 11, the name is blah. And here you see exactly what it did. It set name to blah, where ID is 11. Right, so this is in a nutshell how Spring Data and Hibernate work together. And in the next video, we'll actually use them for a more realistic scenario, not just playing around with it. Good. Thanks a lot for your attention, and see you next time.